All right, Algebra 1 students, let's look at Unit 6, Lesson 6, Building Quadratic Functions to Describe Situations, Part 2. So we're basically continuing what we started with the last video. Our goals are, I can create quadratic functions and graphs that represent a situation. So here we're going to be diving a little bit deeper into our situations. The first one was focused mainly on falling objects. Here we're going to kind of expand that idea. I can relate the vertex of a graph and the zeros of a function to a situation. So when we look at graphs and functions, we will have two very important parts. The vertex, or the place where a graph starts decreasing and then switches to increasing, or vice versa, where it's increasing and then switches to decreasing. And we also have our zeros, which are any place where the graph hits the x-axis. All right. I know that the domain of a function can depend on the situation it represents. So each domain will be relative to what we're talking about, such as sometimes we can't have negative x values, or decimals aren't acceptable in certain situations. So the domain may change based off of what we're dealing with. All right, so our vocabulary is quadratic function, which, remember, that is just the idea of taking an input, putting into a quadratic expression, something with the power of 2, and then getting an output. Vertex, point where a graph changes from increasing to decreasing, or vice versa. So this is the idea of it's going up and then it hits kind of a high point and then it goes down, or it's going down, it hits a low point and then it goes up. That low or high point is considered the vertex. Zero, an input that yields an output of 0. So if we take an x value of 1 and put it into the problem, and we get an answer of 0, that 1 would be considered a 0. All right, this warm-up is going to take a little bit of time. Try your best to fill it out, and then we'll check if we've filled it out correctly tomorrow, and then we will use that to kind of build our understanding as we go forward. So a cannon is 10 feet off the ground. It launches a cannonball straight up with a velocity of 406 feet per second. Imagine there is no gravity and that the cannonball continues to travel upward with the same velocity. So it will always go up 406 feet per second because there's no gravity pushing it back down. Complete the table with the heights of the cannonball at different times. So at 0 seconds, it starts at 10 feet off the ground. So if it goes 406 feet in a second, at 1 second, you would need to add 406 to 10 and then fill the rest out. Write an equation to model the distance in feet, d, of the ball t seconds after it was fired from the cannon if there was no gravity. So that's what we would put in this t spot right here, is the math problem we think is modeling this table. All right, bring that table to class tomorrow. We'll check if we've done it right, and then that will start our discussion as we look more into quadratics. Thanks.